My name's Deborah Fowler, and I want to introduce you to proceduralism in Houdini. This is a gentle introduction. I have other videos that go more into depth, but this is for the very first beginning Houdini user. So this is Houdini that I have open, 18.5.351 at the moment. I can see my scene here. We're going to have parameters and a network view. So let's just create a sphere. Now there's two ways I could have created the sphere. I can either do this from the shelf tools, or I can work directly in the network view. I tend to like to work in the network view, but Houdini offers you every possibility. So you can use Houdini like any other 3D package, but what I want to focus on is how to use expressions. So Houdini, it's very convenient to be able to type things directly into the parameters. So for example, I could create an expression here using HScript, and right now I have a bouncing ball. I'm going to turn the real-time toggle on so it's not so fast, and I will see that it's actually bouncing very slow. I will then change my expression. So I'm retrieving the frame using $, and my frame is the symbol for frame number. So now you can see that I have a very fast bouncing ball. If I reduce the multiplier, I now have a very slow, nice bouncing ball. Now, sine curve is just a function that I've called, and I've given it the argument $f times 10, which is just the frame number sped up. Okay, so that's the basics of actually procedural animation. We get more and more interesting expressions. We can create cooler things. Let's go back a step. This is a node container. This node is in the object context. If we dive inside, that's where my sphere or SOP is. What are SOPs and DOPs and ROPs and POPs and BOPs and all of these different names, essentially to give you an idea of what context the nodes are in, but they're nodes. And what are nodes? Nodes represent code. So this is a node that creates a sphere on your OpenGL preview here. Your graphics library is drawing on your window. Let's make a circle of spheres. Well, one way to do that would be to simply take a circle, create it as a polygon. Now it has points, and copy the points. And now we have a bunch of huge spheres on the circle. Let's make the circle bigger. And let's hit space G so we can see it. So we now have a sphere that's copying on to the points of the circle. So this supplies me with my point information. I copy to those points. You can always float on these little inputs so that you can see what you're supposed to put into those inputs. So geometry, points. And there are ways to look at what information is contained. It cooks to the blue flag. In other words, it processes those nodes. So you can see here, I'm processing only the circle. Here, I'm processing only the sphere. And here, I'm processing the circle being used to copy source points. And I'm using a sphere on those points. Okay, great. So that's one way to do it. Let's do it another way. So let's move this aside. And let's instead, I'm going to use yank to disconnect. So a hotkey is Y, disconnect. And I'm going to create instead a copy node. And what I want to do is create the expression of a circle, which I happen to know from back in the day in trigonometry, where a circle is just defined by a radius, and some angle that we sample will give us a circle if we go 360 degrees, right? So if we do 36 copies, for example, and we rotate 10 degrees, I'm going to take the copy number, which I can get from the copy node. It's just counting like it would in a loop, for loop, for 0 through the 1 less than the number of copies. I'm going to multiply by 10. That will give me 360 degrees. So I'm taking all of those points and creating them. And I'm going to just be lazy and copy parameter and paste expression in this case. Change that to a sign. and I now have a circle. But it looks weird because it's off center. That's because I have transformed cumulative on. I want to turn that off because I'm telling it exactly where it should be. Now in this case over here, let me just plug this in so we can compare. I had size 10. So let's go ahead and multiply the radius in this equation. And you can see that I have the same result. So those are two ways that you can create a circle of spheres. What this allows you to do is use whichever solution you want to use. Now, I love expressions because I can use things that other people have defined. For example, there's an equation that a biomathematician published in 1979 to describe the head of a sunflower. And I can very easily take what was described in polar coordinates, in other words, radius and angle, convert them into Cartesian coordinates, x and y, and I can get a pattern that appears to have spirals in it. Let me show you that very briefly. I'm just going to change this to the square root, and I'm going to change this angle to be the golden angle. I'm going to do the same thing here. And here. And what you start to see is the phyllotactic pattern. And let's turn off that manipulator. That's this tool over here. We're just going to hit select so we don't see that. So now we have the phyllotactic pattern. So very quickly it allows me to create scenes of complexity with a few expressions. And that's why I want to use expressions instead of just plugging in nodes. So what it allows me to do is customize those nodes for my purposes. In fact, I can even use a node called the point wrangle node to type in vex code. That's going a little further than we want to go yet today. So let's do something simple with our sphere. Let's get used to expressions by building a snowman. And we're just going to do a very straightforward snowman. So we've got a sphere here. And what I'm going to do is make that sphere sit on the ground plane. Because right now, if I put a ground plane on here, take a grid, merge that together, and you'll see that that grid is cutting that sphere in half, and we don't want that. So what we can do is very easily take this and say, well, that's the radius. Just rise up the height of the radius. But the problem with doing it with a hard-coded number is if I decide to change the size of my sphere, it's going to intersect again. So the beauty of using expressions is, the defaults are 1. The beauty of using expressions is I can just grab this and paste it in here. And then what it does is no matter what this value is, it's going to sit on the ground. So let's take a look at that a little more closely. Ta-da! Okay, so that can be very handy. Now, what I want to do is create my snowman so that he can be procedural. In other words, I don't have to worry about what the values I've chosen, or if I want to change his size. I can make my own interface so that that gives me that choice. I'm going to turn on point display off. Okay. All right, so let's go ahead and just do a very simple snowman. There are better ways to do a snowman, and I've got a video on that, but let's just start with something simple. So let's create a second sphere. So I'm just going to hit Alt and drag, and that gives me a second sphere with those expressions in it. I'm just going to join that to my merge. Now I like to make sure that all my things are in order, so I just move that so that it's connecting that in that order. Okay, so I have my second sphere, and maybe I should rename these so I keep track. So I'll call this sphere base, call this sphere middle. You can also color code your nodes by hitting C, and that gives up a color palette, and you can then color them whatever color you might want. I'm going to just leave that off for now. I just hit C and then C again. Now, what we've got here is a sphere and another sphere. And this sphere is also on the ground plane, as you can see, which is good because what we want to do is move it to the top of the sphere. And there's a couple of ways we can do that. Let's just transform that. Essentially the height of the sphere. Well, what is that height? It's just twice the radius. So what we can do is copy this and paste relative references. And then what we have is another sphere sitting on top, but you'll notice it's intersecting. Why? And the reason is we have this base sphere and we have this sphere, which is being translated up, but it's not being translated up by the proper amount. So we've added the radius, but we want really twice that radius to get the diameter. Okay? So now we have our sphere sitting on the other sphere. Now it doesn't matter what size or what I do to my middle sphere. It's still going to sit on top of that sphere because we made it relative to that first sphere. Okay? Let's build another snowball. So we're going to do the same thing. But now what I have to do is I have to, and again, I'm going to just go and make this so that it's neat and tidy. I now need to do something with this. So if you look at this, this is a sphere. It's another sphere. And this is my third sphere, which is again on the ground. And I'm anticipating that that's going to be the head. I'm going to shrink that down. Okay. Now I'm going to transform this so that it sits on top of both of these things. So there's two ways I could do this. The first one, well, we obviously have to go as far as this guy went. So let's just copy that. And we now have an expression in there based on the first one. But that's not going to cut it because that only puts it right on top of, and if I hit W for wireframe, I've got a sphere inside there that is not where I want it. So what I need to do is add also this guy, right? So I'm going to copy that parameter, go in here, and make sure that I can type this, and then I'm going to paste that reference. So now I have the middle reference, radius reference. I'm going to multiply by 2 to get the diameter, and there's my head. Okay, so I've squished these spheres, I've made them different sizes, and everything still works. And that's the beauty of proceduralism. This gives me essentially a snowman tool that I can manipulate. I can even add some top-level controls so that I have parameters where I don't have to click on each node. So that is the essence of proceduralism, to get you to the point where you can create the variation and more easily create models that are complex and varied and use them in your scenes. Good idea to stay neat and tidy in your network. And if you're wondering where the origin is, if I invis this, you can't see it. Hit D, go to Guides, Origin Snowman, and you will see now your little helper. Okay. Now, the other thing I want to mention is Houdini has context. So right now I'm in the object context. That's where my lights and my objects and everything that I create in the scene are contained. So I really should call this not sphere object 1 because that doesn't make sense anymore, but snowman. That way when someone else comes into my file, they'll know what's going on. If I were to create lights, say a sun and sky, again, you can see this is kind of messy. So what I do is neaten it up and then lasso select and choose a network box, for example, and I could call this lights. The other thing I know that I'm going to need is a camera. So I can create it here, I can create it here, I can create it with tab. Let's just create it here. It will make that camera, and I'm going to put it in here just to keep it in package, neat and tidy. And I might end up having multiple cams. I can lock the cam and move around, and that will save my camera, or I can not have it locked, move around, As you can see, I still have my camera. But if, let's say I wanted to adjust it and I forgot to lock it, I can always say, save view, camera 1. Okay. And now you can see with my camera, let's just move around a bit, go back to cam 1, you can see I'm still in my camera. Okay, so let's go back to that snowman. So let's create a parameter that controls the base size. Well, I might be tempted to do this, but then I have to put that size in each one. So what if I use this? Well, you notice it breaks. So what's going on? Well, I haven't taken into account that the scale factor is going to act on the radius and thus the center. So if I'm going to do this, I need to multiply this by the scale. And that way, this changes. And when I go to reference my numbers, that will help. But I have to do that in all of them. So let's go ahead and do that. Now, this expression that I'm doing is just saying, grab the channel reference. In other words, give me the path and give me what's in that parameter. So if you look here, rad x, rad y, rad z, I'm just grabbing rad y. And then I'm multiplying by the scale. And then I'm going to do the same thing down here. Now, it's still not going to work because I referenced, instead of referencing this value, I reference this value. So I either need to go in here and multiply by the scale. Oh, I left out my times 2. There we go. Okay, so now I've got the second one working, and I need to go back to this one and multiply this by the scale. And then also this by the scale. Now, if you find typing into that little window kind of annoying, and let's just make this a little more like a snowman. Let's make these back to just make them a little bit more like a shrinking snowman. Now that we've got scale working, just do it with the scale. Okay, so now I've got my little snowman sitting in my house, or I can go back to camera 1, see where I am. And this is now working just based on my values here. And you can see now it doesn't matter what size I make that base, it all still changes accordingly. So we could actually make a control on the top level with one value that will control the size of my snowman. Now, there's other ways to do this in a more procedural way, in a way that allows me multiple snowballs, and that's in another video. What I want to concentrate on right now is just showing you the process. So, and here's a geometry spreadsheet. This tells me information about this particular object. So it has a bunch of points, and in fact, if I scroll down here, you'll see it's got 265 points. If I middle mouse or hit information, you will see that there's 266, 0 through 265 points in this particular piece of geometry. It's got 288 polygons. If I change this to a primitive, it has 1 point that then represents that particular sphere. So your geometry representation is described in here with your point attributes, vertex attributes, primitive attributes, and details attribute. So if, for example, we added a color to this sphere, what would happen is we would add a color attribute. So in this case, green, purple, or whatever you might want to make it. So it now has a color associated with the point. So what we're doing is we're manipulating attributes. So this is essentially the way in which we make things interesting. So for example, if I wanted to make something different colors, I can do that with a color node. I could also do that with a randomized node. Lots of ways to work. So you'll notice that it's giving me this warning, and that you should pay attention to. So what it's saying is, oh, there's a mismatch of attributes, color. Well, in this case, I did that on purpose, and I'm fine with it. So what you can do to the next person coming into your file, which may be you at a later time, you can just put a note saying, warning due to color. And then you know that essentially you set an attribute for your one sphere, your body, and you didn't set a color for your other parts. Okay? So that's just an introduction to expressions using HScript. There's lots more we can do, but I wanted to give you a just really gentle introduction to expressions. Now, the most common thing that we do is we put down a box and you make that box sit on that grid. Let's go ahead and do that. So I'm just going to copy, paste relative reference, and multiply by 0.5. So what that's doing is it's putting the box so that it's sitting on the ground plane. Now let's do a stack of boxes. So we have this sitting on the ground plane, and what we want to do is create some boxes on top. Most typically what we'll be doing is we'll be creating some kind of building, perhaps. So we have some boxes. Let's take this box and make another box. While we're at it, let's create some top level controls as well. I'm just going to merge these boxes together. Now both of them right now are on the ground plane, so they're on top of each other. We're going to change that in a moment. But to start, what I want to do is create a user interface and drag and drop these over here just to make it so that we're working toward our goal, which is to have controls. So we're going to have width, and I like to follow the naming convention where you have your parameter name in lowercase and your label with uppercase, but make it easy for the user to know what your parameters do. And we'll make this number of floors, and we call it num floors, but num floors might not be as meaningful a label. So let's call this number of floors. And again, these are just parameters that are going to appear when I hit apply. You can see we've got sliders, not the best defaults. Let's go back and revisit and create a better default for this. Maybe the width of 3, depth of 2, and number of floors. 0 is fine for this one because maybe we don't want extra floors. As soon as I hit apply, you can see those defaults are now on the slider. So if we hit create, revert to default, they'll go back to that value. We're done with that. I'm going to dive inside here and actually reference those. So we can either copy the parameter and paste, or we can just type in the expression, which is the channel function, which is receiving the current value of that channel or of that parameter given the path. Okay? And then we're going to copy this same thing into here, or we could reference the previous box, either one. Paste expressions or paste relative reference. Paste expressions will say //width. Paste relative reference will refer to the previous box. So you can see here, box 1. In here, if I paste expression, I get the width. Either one's fine. We're also going to do this with depth. And that we will copy and paste into here as well. And I'm going to paste expression. Okay, so now we have the width and depth controlling our boxes, but these boxes are still on top of each other. So we're going to be creating extra floors, for example. Maybe we're doing the building. So I'm going to do a copy node. And again, lots of different ways we can do this. But we're going to create a copy node. And again, I'm going to refer to that number of floors. And go ahead and trust help you. Okay, so right now I have 0 floors. I have 0 second floors. And I have 1 first floor. And I probably should call this something meaningful. You can also label them with colors. So I could make this color so I could identify it more easily. once we start getting larger and larger networks, that becomes important. So this right now is not giving me any floors. I'm going to go back up and create a couple of floors. But right now, I'm not moving. They're on top of each other, which we've covered in the copy node. So if we translate cumulative, well, we get our multiple floors. But the problem with this is that now they're on top of this initial box, and that's not what we want. If we try and put expressions in here, it's just going to continuously accumulate that value. So we're going to turn that off. And you can see here it went past first floor. But really what we want to do is if we decided to change that floor, we'd want to have a reference to it. So we're going to copy that parameter and paste relative references. So now we have the size of that floor plus the copy number times the size of whatever my current floor is, which happens to be 1. But to be really accurate, I should copy that parameter as well, just in case I decide to change it, and put that in here. Oops. Put that in here. So let's go ahead and grab this and go ahead and multiply by that value. And so let's go ahead and multiply that value. So I'm going to paste relative reference, and you can see that it's now grabbing the size of that second floor. So if I want, I can click into this window and do Alt-E so you can see it a little more easily. And there we see that we're going up the first floor, and then for every subsequent floor, remember that copy number starts at 0, goes 0, additional, and then 1, and 2, and so on, for whatever size that is. So let's take a look at the whole thing. So we have 2 floors. If we have additional floors, you can see that's all working. Depth and width controls my configuration of my overall building overall. So we have this nice little tool now to create a stack of an initial block and additional blocks. And we could add controls also to manipulate. So for example, the first floor might be taller. You can see when we turn it into wireframe by typing W that we are getting the correct thing. Okay, there's no intersections there. So what if we wanted to put windows on here? Well, whatever we feed into this copy node, if we merge together, say, another box to represent a window, let's go ahead and do that. And I'm going to make this window part of that object, but right now, if we wireframe, you can see it's inside. What we want to do is move it out to the front. Now we can either do that in another transform node, or we can just do it here. So what I'm going to do is depth, but we're focusing our building on the center, so I'm going to multiply by 0.5. So that moves it in front, and it's still centered, so I'm going to make this a little skinnier. I am going to have it protrude for right now, and I'm going to move this up just a little bit and maybe reduce that size. Okay, so now I have a window, and it's copying on as a unit. And again, I have videos on how to do an entire building, but just to give you a start. So I now have a stack of blocks with this feature because I'm merging this entire unit into the copy node. It's copying them all into place. That can be a very powerful technique. Now there's a couple of ways that I can add a roof. So let's go ahead and again, Alt or Control-C, Control-V. We're going to grab that and I'm going to call this roof. And this roof is going to be sitting on the top of the building. So probably we want to make the roof pretty short. Shouldn't be as tall as the building. And let's make it even shorter than that. So I now have a roof, as you can see. Let's make this 0.3. So there's my skinny little roof sitting on the ground plane, intersecting right now the floor. But we want to move it above this entire unit. Well, we could reference, much like we did in here, could reference the first floor plus the number of copies, or you could use another function. So if you look at the merge node and you look at the information, you can either middle mouse or you can use the radial menu and hit I. You'll see that there's a center point, a minimum and max in X, Y, and Z. So min X, min Y, min X, max X, size X, min Y, max Y, size Y. So that 5.4 really is what we want. But we don't want to use that number. We want to actually use an expression. So I'm going to transform this And rather than merging it in here, I'm going to cut that by using yank. And then in here, I'm going to add this to this merge. And I like to keep my inputs correctly going into the merge like that, just for neatness. I'm going to merge it in. So what I'm going to do is I'm going to move it that amount, so that 5.4. So if I hard-coded it, it would look like that. But as soon as I changed my building configuration, it would break. Instead, what I do is I take the bounding box value, and that's a function that I can use based on the merge node. It gives me essentially the string, in other words, the path of the node, and what of these values do I want? Well, I want dy size. So I'm going to use comma d underscore y size. And now what it does is it automatically takes me to the top of that object. So that's an easy way to add a roof. I might want to make the roof a little bigger, either by multiplying or adding a value. Let's just do that. And now we have a nice little start. Okay. So hopefully this has helped you get more comfortable with expressions. We've done circles of spheres, we've done snowmen, and we've done a stack of boxes. That's essentially one lecture. So the other ways of doing things are to use more expressions and use an expression language called VEX, and we can start using point wrangles. This is all for another time. So thank you for watching. Hope you enjoyed it. Bye for now.